The transformation from R2 to R3 is given by T of x equals A times x, where matrix A is the given 3 by 2 matrix. We're asked to find vector x, the input vector, or the preimage, whose image under T is the vector -12, 0, -4. So we're looking for the vector x, where matrix A times vector x, which is in R2, and therefore the components are x1, x2, must equal the image, or the output vector, which is the vector -12, 0, -4. We know how to solve a matrix equation like this. The next step is to write the augmented matrix for the system. Because we have 3 equations and 2 unknowns, the augmented matrix will be a 3 by 3 matrix, where the first row is -2, 2, -12. The second row is -2, -1, 0. The third row is 0, 1, -4. And now we need to write the augmented matrix in reduced row echelon form. Let's replace the first row with -1/2 times row 1 to get a leading entry of 1. Let's replace row 2 with -1 times row 1 plus row 2 to get a 0 in row 2, column 1. -1/2 times row 1 gives us 1, -1, 6. And now let's replace row 2 with -1 times row 1 plus row 2. -1 times -2 is 2, plus -2 is 0. -1 times 2 is -2, plus -1 is -3. And -1 times -12 is 12, plus 0 is 12. Row 3 remains the same for now. Now let's get a 0 in row 1, column 2 by replacing row 1 with row 1 plus row 3. Let's replace row 2 with -1/3 times row 2. Replacing row 1 with row 1 plus row 3, we have 1 plus 0, which is 1. -1 plus 1 is 0. And 6 plus -4 is 2. Replacing row 2 with -1/3 times row 2 gives us 0, 1, -4. Row 3 remains the same. Notice row 2 and row 3 are the same. Let's replace row 3 with -1 times row 2 plus row 3. Row 1 and row 2 remain the same. Replacing row 3 with -1 times row 2 plus row 3 gives a row of zeros. Let's label the first 2 columns x sub 1 and x sub 2. The first row indicates that x sub 1 is equal to 2. The second row indicates that x sub 2 is equal to -4, which means vector x, the preimage, or the input vector, is the vector 2, -4, when the output vector, or image, under T is the vector -12, 0, 4. I hope you found this helpful.